Okay, so this section is about quadratic functions, some of which we've already done, but we'll go through all the different things that are a little bit of review and then also new. One of the first things you need to be able to do is graph. You should already be comfortable how to graph something like y equals x minus 1 squared plus 4. We did that last unit. This is what we call vertex form. The reason it's not very difficult to graph is because you know what the vertex is by looking at this. Since the vertex and every other point shifts right 1 and up 4 units, the vertex, instead of being at 0, 0, is at 1, 4. Okay? So the official vertex form, whoops, looks something like this. Y equals a times x minus h squared plus k. With vertex at hk. These are the types of equations that you should be comfortable graphing because you can see what the vertex is from looking at the equation, and it's not very difficult to do. Okay? If the equation is in standard form, meaning it's all multiplied out, so it's like ax squared plus bx plus c, now it's not so easy to look at that equation and say, oh, well, the vertex is here. Okay? Because you can't really tell what that vertex is yet. Okay? So one of the things I'm going to show you with one example is how to take standard form and put it in vertex form. Because if you can take this equation and put it into vertex form like this one, you should be able to graph it. Okay? Then there's also a shortcut that'll help us find the vertex. So we'll talk about those two things. Okay, so with this example, I'll ask you every possible detail that I'll ask you about quadratics. So here's a function in standard form. I don't know where the vertex is. Okay? If we complete the square, kind of like what we did with circle equations last quarter, what I'll do is take out a 2 from the x's so that it's normal, just x squared. And if I take out a 2 from 8, that gives us 4x. And now we have to figure out what the magic number is. You guys know it. What is it? Okay. Now if I put a 4 in here, you can't just add 4, which actually has what value?
8.
If you add 8 to one side, you should add 8 to the other side to keep things balanced. Okay, and now simply all we have to do is rewrite this. So f of x will be 2 times, if we write this out, when you factor it, we get x minus 2 squared. And if I move the 8 back over, 5 minus 8 becomes minus 3. So now this equation and this equation are the same thing. Two different ways of looking at it. This one is nicer if we're going to graph. So, here are the things that I would ask you to find. I would ask you to find the vertex. I would ask you to find an axis of symmetry. I would ask you for whether there is a max or min, and to tell me what that max or minimum value is. And I would also ask you possibly for x-intercepts and y-intercepts. Okay? So now, to graph, let's see. So if I'm going to graph this function, maybe the only thing that's throwing things off here is that there's this 2 in front of the parabola. Okay? So then, here's what I'd like to do first. Since there's a 2 there, I want to kind of look at what 2x squared looks like instead of the regular x squared graph. Everybody knows what x squared looks like, right? What are the points? 0, 0, 1, 1, 2, 4. So 2, 4. Now, and we do the same the other direction. If I put a 2 in front of the x squared, then all that changes is that the y's double. So instead of going to 1 and 1, we'd go to 1, 2, and to 2, 8. So this is the graph that we're talking about here in purple, that we're going to shift according to these rules, which are to go right 2 units and then down 3 units. Okay? So when I graph a quick sketch, I'm going to do the same pattern I just graphed, but starting at the vertex, which is what, by the way? 2 and negative 3. So if I go to 2 and then negative 3, here's the vertex. I know that instead of going over 1 and up 1, I'm supposed to double how far up I go, right? So I'd go up 2 units instead of 1. And if I go over 2, normally I go up 1, 2, 3, 4, right? But since it's 2x squared, we double that. So I'm going to go up 8. Same if I go left 2. Left 2, up 8. So then this is your parabola. Okay? Axis of symmetry, if you forgot from Algebra 1 or 2, is the vertical line that splits the parabola in half. Vertical lines always have the equation x equal to something. Do we know what x equals here? So that's the axis of symmetry. Now, looking at the parabola, is there a lowest or highest point?
Lowest.
So that means that this has a minimum value. And looking at the parabola, the lowest point on the graph, we're always going to use the y value. What is the lowest y value? Negative 3. Okay. X-intercepts and y-intercepts, we still find the same way we've been finding them. So to find the x-intercepts, unfortunately our graph doesn't really tell us much about what they are. It just looks like they're close to 1 and 3, but they're not exactly there. So how do we find them by hand? So plug in 0 for y, or f of x. You have two options, okay? You could plug 0 in at the very original equation and then use quadratic formula. Or, if you've done a nice job completing the square, you can plug 0 in here, and then you can avoid using the quadratic formula, because then you can just get x alone. Okay? So I'm going to use this equation, set it equal to 0, because why use the quadratic formula if we don't have to, right? How do I solve for x? Add 3, divide by 2, square root both sides. So then you get x minus 2 equals plus or minus the square root of 3 over the square root of 2. we don't want the square root in the denominator, so we can multiply by root 2. So we get plus or minus root 6 over 2. And what's the last step here to get x alone? So I'll just put positive 2 on the other side. You can put it after, like plus or minus root 6 over 2 plus 2, or you can put it in the front. It's the same thing. So then my x-intercepts would be 2 plus or minus the square root of 6 over 2, comma, 0. Those are the exact values for the x-intercepts. If you type this in the calculator, you should see that it's pretty close, or at least in between 0 and 1 and in between 3 and 4. Okay. Now for the y-intercept, we plug in 0 for x. So looking back at the two equations we have, I don't know about you, but this first one seems nice because if you plug in 0, what happens? This x term cancels, that cancels, and we just get 5. Which you could also look at your graph. We already graphed the point 0, 5 as we graphed it. So, I mean, there's two ways that you can think about it. Okay. Are there any questions on this example?
Yes.
Mo? Well, close. If you plug in 0 here, it becomes, yeah. So it looks like you'd get negative 3, but yeah, be careful here. You do get 5. Jenna?
For completing the square, when you multiply that by, or when you get the 2 times 4,
Yep.
then it's 8 on that side. So why did you add plus 8? Wouldn't you subtract 8 on the other side and then 5?
When you keep things balanced on an equation, you're supposed to do the same thing on both sides, right?
No, I know, but like, if you do 2 times 4, it equals positive 8.
Right, so then I should do positive 8 on the other side.
How'd you do it? What happened to the positive 8 on the right side?
Two and 4 means I added 8 on the right.
Yeah.
So that's why I also added 8 on the left.
Okay. Then subtracted them.
And then I moved, I moved it over.
There be another 8 on this side, so it's 5 plus 8 minus 8, and just equals 5.
If you add 8 here, then now you're adding 16.
Yeah, but you just said you added things.
The 8 is already here from the 2 and the 4.
Oh, okay.
This number here wasn't there originally, right? We figured that needed to be there to make the perfect square.
Mm-hmm.
So that's why, since I put this there, it looks like I'd add 4 on both sides, but since the 2 would get distributed to it, I would actually add 8 to the other side. And then I subtracted over to get negative 3. Okay.
And then,
Go ahead.
for the graph, when you're graphing it, how did you graph that?
I first graphed the parent function,
Okay. Yeah.
which was 2x squared,
But how do you know it's 2x squared? Why wouldn't it just be x squared?
because there's a 2 in front of the x squared.
And then you just like did the
Move it around. Yep. Katie?
What's the actual symmetry
Because this is the symmetry line. Like if you think of the graph, this is where you'd be able to fold the piece of paper.
Hey, put that back. Is it always a middle?
Yes, so that on either side it's the same shape. Does that make sense? That's like a mirror line almost. Okay?
That's where you put the mirror to reflect it.
Yep. Anything else? Okay, guys. I'm glad that we were all able to be quiet. But now see, here's what happens. As soon as people start asking questions, those of you who think you know what's going on, guess what you start to do? You start to use your phones, talk to other people, and ignore the questions that are asked, which really you could probably benefit from. Okay? Anything else before we move on? Okay. Now, this was the first option to graphing and finding all the vertex and all that stuff. We're not going to rework the whole thing again, but I will at least find the vertex for you. The second option is to use the shortcut to find the vertex. Which probably will look familiar. At least I hope it does. the x-coordinate of the vertex for a quadratic is always the opposite of b all over 2a. Does this look familiar?
Part of the discriminant.
Okay. So, referring back to the previous example, if we had f of x equals 2x squared minus 8x plus 5, and all we cared about was finding the vertex. Because sometimes, honestly, that's all we really need. Maybe we don't care about the y-intercept or the x-intercept, but we just want to know where that vertex is. Instead of completing the square and doing all that, you could just do x equals negative b over 2a, which will tell you what the x-coordinate is. So what would opposite of b be here? 8. 2 times a is 2 times 2, so 8 divided by 4 is 2. So currently, according to the shortcut, I know that my x-coordinate for the vertex is 2. How do you get the y? You can plug in the x value. So then you would do f of 2 is 2 times 2 squared minus 8 times 2 plus 5. So that will be 2 squared is 4, double it is 8, subtract 16, add 5. Negative 8 plus 5 is negative 3. So here's your vertex. So you can either complete the square, or remember this rule will always help you find the x-coordinate of the vertex. And once you know x, you can find y just by plugging it in. Any questions on how to use the shortcut? Jenna?
When would you want to use the shortcut rather than...
Whenever you don't want to do all that work.
Okay. So that one's always pretty much going to be easy?
Yes. Unless there's a... And let me be clear. You need to know how to put it in vertex form, because there's other applications. Like sometimes you want to know what that equation looks like. But if all you care about is where's this vertex, you can just use the shortcut.
So the first one is just putting it in its form?
The first one we put in the vertex form, and then by completing the square, right? And then we found all the details we needed to find out from there.
And then which value is the vertex? Like for the graph above, the little the parabola that you drew?
Yep.
Which one is the vertex again?
The vertex is the lowest or highest point,
Oh, lowest.
or highest, depending on which way it opens.
What is the line?
Then there wouldn't be a vertex. It's only for parabolic functions. Anything else? Okay. Now, here's where it gets a little bit newer. Max and min problems. Quadratic functions are some of the most common real-life types of functions that you see based on, well, things that occur in nature, like falling objects. What else? When you throw a football, I mean, a lot of things have a parabolic shape. So a lot of times, especially in physics, you might see quadratic equations. And sometimes you're interested in what the highest or lowest point is, and that's all. Okay, so if that's the case for these max and min problems, my advice is to use a shortcut to find the vertex. And now, once you know what the vertex is, so let's say your vertex is x comma y, the x value is called the input that minimizes or maximizes, depending on the context, the function. And this y value, that is the min or max. So if I ask you, tell me the minimum, you would just give me the y coordinate. Okay? If I say, what's the input that gives you the maximum value, you would just tell me what the x value is. Okay, so it all depends on what the questions ask. Here's a quick example. Let's say y equals 6x squared minus 14x plus 5. Okay, oh, and by the way, all this stuff is stuff that you'll be doing without a calculator for this unit. Okay. Yes?
Can I ask a question?
Sure.
Okay. Oh, that wasn't a question. But, so you said that when we have, like, when we were doing the parabolas, you said we're either going to have a linear max. But how am I supposed to know that when the question's like only asking for one of them? What if it's asking for both?
A parabola can't have both.
Exactly. But, like, is the question only going to ask for min if it only
It'll
says
say
min?
find the max or min. You have to decide what it is.
Oh, it's not going to be specific?
Right. Now, that's a good question. How do we know if there's a max or a min? Yeah, if the parabola opens up, then it's a minimum. Well, you should know if there's a positive x squared or a negative x squared, right? That determines whether it opens up or down. Yeah. Okay. So, for example, here, this has what? A max or a min?
Wait, you just told how we know?
Oh.
How do we know that this has a minimum?
Because it opens up.
This opens up.
What do you mean it opens up?
The parabola looks something like
How do you
that.
know it opens up or not?
Because this is positive.
Oh, so just the first number?
Yep.
So what if it's negative means it closes?
It opens down, and then there's a maximum. Okay. So, if I want to find that minimum, what is the minimum? You could complete the square and do all that, or the shortcut will help us.
Oh, this makes sense.
Negative b over 2a will tell us what the x-coordinate for that vertex is. So that would be 14 over 12, which is 7 over 6, yes. And now to actually find the minimum, you got to plug it into the function. So then y would be 6 times x squared, so 49 over 36, minus 14 times 7 over 6 plus 5. And if you simplify, this is the same as 49 over 6 minus 98 over 6. 5, since these have 6's already, I might as well put that over 6, so that would be 30.
You can just do that. Put over 6.
Yep.
Why did you put it over?
Because these already have 6 denominators, so if I'm going to...
Not above that. Why did you put 49? Yeah, where did you get that?
Yeah, where
Did you multiply by 6? Why did you multiply by 6?
X squared, right? So if x is 7 6, that becomes 49 over 36, right? Times 6, you can either multiply it the long way or recognize that 6 over 36 reduces to 1/6, right? Makes it a little easier. And since these all have 6's, that's why I put the 5 over 6. So then my final answer, negative 49 plus 30, is negative 19. So my vertex is located at 7/6, comma, negative 19/6. So what's my answer? What is the minimum? Negative 19 over 6. Very good.
Because he needs to put it over 6, so you multiply by 6. Oh, okay. You should write that in
Because it opened up. So the lowest point would be the minimum. Okay. Are we good on this? Do we need a maximum example or can we handle it? What would the only thing be that's different if it's a max question? This will be a negative number. Everything else is the same. You still do the shortcut. You still plug it in, right? Everybody got it? Okay. Now, the max and min for quadratic types. Sorry,
Wait, what was the x value again for that last one?
7/6.
What? Oh yeah.
Okay. In chapter 2, a long time ago, we dealt with equations that were like x to the 4 and then x squared, or x to the 6th and x cubed. Already you guys know. Very good. When you see a quadratic type of equation, we can't do the shortcut until you make it quadratic first. So yes, you're going to use a substitution. So here's an example. Let's say f of x equals negative x to the 4 plus 6x squared plus 10. This looks like it's quadratic because it's 4 and 2, right? As long as this exponent is double the middle one, then we're good to go. What should I let u be?
U squared. X squared. X squared is like next.
So then f of u will be negative u squared plus 6u plus 10. Now this is quadratic. And now this is the place where I've seen students make silly mistakes. We're going to use a shortcut like we did before to find, and what are we finding here? What would you guess?
U.
Which one is it? Y max? You got a negative in front, so it's up, opens down, so the top point would be a maximum. Okay? Right here, when we use a shortcut, I know the formula says x equals negative b over 2a, but I wouldn't write it like that because we're actually using u as our variable right now. So u is negative b over 2a. So that when you find the shortcut for u, let's see, opposite of b is negative 6, 2 times negative 1. I get that u is 3. This is not the x value. This is the u. So what is u? U is x squared. So I'm going to go back and change it so that I actually know what x is. To find x, we square root both sides. So you get x is plus or minus root 3. So these are the inputs that give us a max. There's two possibilities, and you can see why. Because if you plug in positive root 3 or negative root 3, you're going to raise it to the 4th. Yes. Okay. Jenna?
2 questions. If it was like a negative x to the third, would there be no...
There could be. If this would have to be an x to the 1.5.
Oh, so these will like determine that?
Mm-hmm.
Yeah, that is a whole... Wait, forget that. How about my other question? Why is u equal to negative b over 2a? I thought x would, like, why...
It doesn't, that's the whole point. It doesn't have to be x. It can be any variable as long as it's quadratic.
I'm saying, but like, to find the...
Because we can't use, because x is up here, right? So you have to make sure you use the correct variable if you're using that substitution stuff.
Okay, so then when you're doing the plus or minus, when do you not do plus or minus?
Cube roots, fifth roots, odd roots, basically.
Odd root.
Yes.
Okay, and then this one... Whatever.
Okay. So many phones. So sad. So, to find the max, what do we do with these x values? Plug it in. You can do either one. It's going to be the same answer. I'm going to use positive root 3 just because it's positive. And if I plug it into the function and figure out what I get, did I do that right?
Yep.
Yes. So then now we just figure it out. Root 3 to the 4th is root 3 times root 3, which is 3. And then another root 3 times root 3, which is also 3. So this becomes minus 9 plus 18 plus 10. So positive 9 plus 10 is 19. So this is the max. If you plug in a negative, it won't matter because either way, when you square it or raise it to the fourth, you still get the same answers. Well, there wouldn't be a vertex because there's two locations, because it's not a quadratic anymore. It's kind of like a quadratic. So they're actually, if you graph this, it would kind of look something like this, where there's two lower points like that. Allison?
Okay, what if it's 3 and 1.5 then? And you have like a plus minus?
You wouldn't have a plus minus.
No, I mean, oh yeah, you're right. Okay, never mind.
One.
3 when it starts with U, can you still just plug it into the original one? Well, to the U equation?
Say that again. If it's
If U equals 3, can you just plug it into the equation of U?
into the U equation.
Yeah.
Yes, as long as you make sure you keep track of where you're plugging it in.
And then you just solve it again for x squared, right?
Yeah, but well, actually, you wouldn't, because if you plugged in 3 right now, look what you're going to get: negative 9 plus 18 plus 10. So you're done at that point.
So yeah, so I'm going to that.
You can, but I see students a lot of times not plugging it into the right equation. I also see students that answer the question incorrectly, because a lot of times it'll say, what is the input that actually gives you the maximum? And because they do the U thing, they say that the input's 3, but really it's not. It's plus or minus root 3. Does that make sense? So, I mean, you can do it, just got to be careful where you're plugging stuff into. Jenna?
From root of 3 to the fourth power, how do you do that?
You just write out like root 3, root 3, root 3, root 3. Multiply it out.
Oh, it's just 9. But what if it was like to the 20th?
You wouldn't have anything that big,
How do you know?
because I'm making your tests.
What if it's on the ACT?
It won't be.
Do you make the ACT?
You have a calculator for the ACT, so you could type it in.
Okay. Fair enough, Mr. Gonzalez.
Okay. The last quadratic type, and this is hopefully going to make everything very clear. Let's say we have something like this. F of x equals cube root of x squared minus x plus 4. So, I want you to, real quick, look at some of the problems we've talked about. This is just quadratic, right? Could we use a shortcut and do x equals negative b over 2a? Yes. This was just quadratic. Could we use a shortcut here? This one was not quadratic yet. We had to do a substitution, right? Do you guys see what I'm getting at? Look at the middle term. The middle term, whenever we did the shortcut straight up, was exactly x to the first. Do you guys see that? When we did the substitution, we had an x squared in the middle, so we couldn't just do x equals negative b over 2a right away. What do you see here for the middle term? An x, just x to the 1. There is this cube root in the way, but that's after the stuff that's going on the inside. Does that make sense? So if we want to find the minimum here, we can still do negative b over 2a, because this is just a quadratic inside a cube root. Okay? So x would be what?
Over.
1 over 2, 1, so 1/2. So there's our input. And now to find the actual min, you do f of 1/2. You just plug it back into the equation. So you do cube root of 1/2 squared minus 1/2 plus 4. So that's 1/4 minus 1/2 plus 4. Common denominator, 1/4 minus 2/4 plus 16/4. Add them all up. What is that? -1, 16 is 15. So then this is your minimum. The cube root of 15/4. What's that? You wouldn't be asked to find the vertex here since this is not technically a quadratic function. But they still could ask you to find the minimum or a maximum. And because there's a quadratic inside of the cube root, it's going to be located at the same x value. It's just the y value will have to be a cube root around it. That's the only difference. Jamil?
Can you solve this by using u again by making the x one bit?
What would you make u?
Like u would equal x1 over 3,
Well, there is no x to the 1/3 here.
but you have a third root over.
Right, but that applies to the function after, like if you follow order of operations. Here, maybe if I draw a picture. Do we agree that this is if I ignore the cube root, it's a parabola? Maybe it looks something like this, okay? Now, if you have a parabola and then you cube root all these y values, what happens when you cube root every single value? It just gets smaller, right? So now maybe the graph looks something like this. So what's the only difference? Well, the x value is still going to be located at the same position. It's not going to be like x to the 1/3. We have to, you know what I mean? So that's why we just use the normal shortcut. The only thing that's different is that this lowest point will be lower than if it were a normal parabola. Okay? Anything else on max and min? Right. Yes. Last thing we need to know is how to determine whether some data is linear versus quadratic. Okay, so I'm going to show you a nice little technique that'll help you figure out whether things are quadratic or linear. Let's say this is 1, 2, 3, 4, 5. Let's say this is 0, 5, 10, 15, 20. Let's say this is the same 1, 2, 3, 4, 5. And let's say this is just 1, 4, 9, 16, 25. Okay, this nice technique. First, you got to check if the x's are all going up by the same amount. Are x's increasing or decreasing by the same amount each time? So if I'm looking at this table, I see that every time I change the x value, they're all going up by 1. You guys see that, right? If I look at the y values, so that's the second thing we do. Now we find the difference in y's. What's going on every time? Goes up by 5. Okay? If the first difference is constant, maybe, I don't know.
No, algebra 2. This is algebra 2. Right?
Maybe you did in algebra 2, yeah.
This is freshman year.
If this first difference is the same every time, then the function is linear. Okay? If the second difference is constant, then the function is quadratic. So here's what it looks like. Here again, we're going up by the same amount, so we can do the test on the y's. Everything's going up by 1s in the x values. But now here, we go up by what?
What does stand for?
Difference, yeah. Here we go up by 3. Here we go up by 5, and then 7, and then 9. Since this first row of differences is not the same, we know for sure that this is not a linear function. Okay?
Can you move it down just a little? No, other way. Oh, my bad.
If I find the difference of the difference, what's going on here?
The same.
Up by 2, up by 2. So this guarantees that this function over here is quadratic. Christy.
Are we always working with the y side?
Yes. As long as the x side is always going up or down by the same. Mo? Because it wasn't the first difference, it was the second. If we extend this and went into, like, let's say the first differences don't give us the same value, the second ones don't, but the third ones do, then it would be not linear or quadratic, but cubic.
Wait, so this one's cubic?
It just keeps going up. Yeah. Austin.
So if you find the difference that determines what other type of function.
Yes. And if the difference of the difference is the same, then it's quadratic.
Wait, did you write that?
If the difference of the difference of the difference is the same, then it's cubic.
Alright.
And it just keeps going. Yep. Jenna?
I write that because I can't understand what you're saying.
Well, it's written right here.
No,
If the first difference is constant, then it's linear. So here you see how I found the difference and I got 5s right away? That's how I know it's linear.
The first difference of the y value?
Yes. Here I did the same thing, but I didn't get it to match. So I did it again. Now I got 2s everywhere. So because it was the second time, that means it's quadratic. 2 means quadratic.
When's it cubic?
If it were 3 times that I had to do it. Okay? This is all I have for you. The only thing I wanted to point out was if you just turn on your calculators real quick. Press stat. Go over to calculate. Which option have we been using there? Linear regression is what we've been doing, right? There are many types of regressions. Now you should also be able to use quadratic regression if we need to, or cubic, and so on and so forth. So just know that that's a possibility. Okay?
What's linear regression A plus B?
It's just a